We start off with our first class of the chapter straight lines. Now, this chapter, obviously, you have some idea from your previous class, that is from class 10. You have done quite a bit. So, in today's class, we are just going to do a few recap of whatever we have done in class 10, and we are going to do some extra bits like different forms of equation of a straight line. So to begin with, let us talk about all those things which we already know. So what is a straight line? Basically, a straight line is basically a breadthless length which extends on both directions indefinitely. So a straight line does not have any breadth, it's just only a length, and obviously it's indefinite. It extends on both sides to infinity. Now, a line segment is basically a part of it, a finite part of the line, a straight line, and it has got two ends. So it starts somewhere and it ends somewhere. So whenever we work with in our real world problem, so generally we take up the line segment and then we extend it to a line. Then if I have a line segment which has got the endpoints as a and b, where the coordinates are x1 y1 and x2 y2, then obviously the distance of that line segment, or the length of the line segment, is given by under root x2 minus x1 whole square plus y2 minus y1 whole square. This is our same old distance formula which we already know, and we have done a bit of it in 3 dimension also, those who are going to opt for section B. So you people have done it in 3 dimension also. There you will have another extra z coordinate. Now also, if I have a line segment with endpoints a and b, and there is a point in between which divides the line segment in the ratio m is to n, then the point is given by mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. Now obviously this is an internal ratio. Internal ratio means that the point of division lies between the two endpoints. So how does it look like? It looks something like this. If this is your line, if these are the 2 points which we already know, if the point C, say, lies in between and it divides the line segment in the ratio m is to n, then we have this formula. And then if I have an external ratio means external ratio looks something like this. If I have the line segment somewhere here AB, and I am trying to find the point C which divides the line segment AB in the ratio m is to n externally means this part is m and this part is n. So if I have such kind of a situation, then this point C will be given by the same formula, except for the plus I will have a minus sign both in the numerator as well as in the denominator. So that's it. This is your section formula, same old section formula, but I guess you haven't done the external part, so this is the external section formula. Fine. Then let us move to the next part. Now say the straight line, as it passes over the x-axis, so in the figure this is my x-axis, this is my y-axis. So as it passes over the x-axis and y-axis, and this is your origin, so the angle which is made by the straight line with the positive direction of x-axis, the tangent of the angle means tan theta, is called the slope or gradient. Now, generally, we don't use the word gradient much. It is more of an Western word to use, but here we use the word slope. So it gives us the idea that how much inclined the line is with the axis, or according to the axis. So if the slope is gentle in the sense, if the value of the slope is less, then it is inclined away from y-axis, and if it is negative, then it is inclined towards y-axis, positive y-axis. So it just gives you how steep or gentle the straight line is. Then how to find the slope if we know the 2 points on the line. So let x1 y1 be one of the point and x2 y2 be one of the points, the other point. Then the slope is given by y2 minus y1 by x2 minus x1, and we are already given how it comes. So if you see here, if we draw this triangle, then by corresponding angle, if this angle is theta, this angle is also theta, and this much is x2 minus x1, this much is y2 minus y1, and we know tan theta is basically perpendicular by base. So from there we have y2 minus y1 by x2 minus x1. And then if two lines are parallel, then the slopes become equal, and if two lines are perpendicular, then the product of the slope is minus 1. So in case of parallel lines, if m1 and m2 are the two slopes of the line, so for parallel lines they become equal, and for perpendicular lines, then m1 into m2 becomes minus 1. So this is how it works. Then now let us move to something which we haven't done in class 10, so we will be doing it for the first time. That is how to find angle between two lines. Now by angle between two lines, now let me just tell you, if I have these two lines, say this is line 1 and this is your line 2. Now obviously when two lines intersect, there are four angles, 1, 2, 3, 4. Now obviously of this four angle, they are all vertically opposite angles. So if this is theta, this is also theta. If this is phi, this is also phi. Now whenever we are trying to find the angle between the two lines, we will be considering the angle lying between 0 and pi. Our angle should lie between 0 and pi. Why? Because if not just only 0 and pi, I should discard pi, because pi and 0, they are all same, because if the angle between two lines becomes 0 or pi, that means they are coincident or they are parallel to each other. So given this, then we have to ensure that whatever value of the angle we find, the angle must lie within this range. So to get that value, we have the formula. If the angle is alpha, so instead of theta, if I consider it as alpha, so tan alpha is modulus of m1 minus m2 divided by 1 plus m1 m2. So that is the angle between two lines. Next, find a point on x-axis which is equidistant from the points 7, 6 and 3, 4. So we take up few examples. So the first question gives you a point on x-axis which you have to find out such that it is equidistant from the two given points 7, 6 and 3, 4. Now we know that any point on x-axis is given by a comma 0 or anything comma 0, because any point on x-axis, the y coordinate is 0. Now let us find the distance from this point to this respective points which are given, and also it is told that they are equal. So we have something like this. These are the distances from that point on x-axis to those respective given points, and also they are given equal, so we can equate them. So now we just need to go on solving it one step at a time, and if we just go on solving it, we get the point as 15/2, 0. Fine. Next, number 2. Find the slope of a line which passes through the origin and the midpoint of the line segment joining 0, -4 and 8, 0. So first we need to do what? We need to find the midpoint of the line joining 0, -4 and 8, 0. So let us do that. We already know what is midpoint formula. If the 2 points are x1, y1 and x2, y2, then midpoint is x1 plus x2 by 2 and y1 plus y2 by 2. So we have done that, and we get the point as 4, -2. Now we need to find the slope of the line segment passing through origin and this point 4, -2. So that will be y2 minus y1 by x2 minus x1. So that is -2 minus 0 by 4 minus 0, and that is minus half. Number 3. Without using Pythagoras theorem, show that points 4, 4, 3, 5 and -1, -1 are the vertices of a right angle triangle. Now to do this, there are several ways you can do it. You can make use of the distance formula, which is something we have done previously, that using the distance formula you can find the distance between the given points, which are the vertices, and if I can show that Pythagoras theorem holds, then it will be proved that the triangle is a right angled triangle. But the question says that Pythagoras theorem can't be used, so we can't use that method. Now what to do? See here, to become a right angle triangle, any two side has to be perpendicular. So like there has to be two sides which will be perpendicular. So if they are perpendicular, slope of this side and slope of this side, the product of their slope should be -1. So let me do what? Let me find out all the slopes of the three sides. I don't know which one is going to be what, so I have to find the slopes of all the three sides and check if there are any two slopes whose product is -1 or not. If I get one, then I can say that the triangle is a right angled triangle. So I just mark the points. Let us call 4, 4 as A, 3, 5 as B, and -1, -1 as C. So slope of AB, that is y2 minus y1 by x2 minus x1. So we just apply that method and it gives you -1. Slope of BC, that is 3/2 as you get, and slope of AC, that is 1. So now we can see that slope of AB times slope of AC, that becomes -1. So the product is becoming -1, and hence the two sides AB and AC, they are perpendicular, and once they become perpendicular, we know that this is a right angled triangle or a right triangle. Number 4. Find the angle between the x-axis and the line joining the points 3, -1 and 4, -2. Now, angle between the x-axis and the line joining the points. So, we already know that if this is our coordinate system and say this is the line which is passing, then the angle made with the positive direction of x-axis, if this angle is theta, then tan theta is basically the slope. So it is always easy to find the slope of a line if 2 points are given. So let me first find the slope and then equate that to tan theta, and then we can get the value of the theta, which is what we are looking for. So to begin with, Let me consider that angle be theta. Fine. Then let us find the slope. So slope of the line, minus 2 minus of minus 1, that is minus 2 plus 1, and 4 minus 3, that is minus 1. Then equating it with tan theta. So tan theta is equals to minus 1. So tan theta is minus tan pi by 4. Now you will be tempted to write this as tan of minus pi by 4, which is basically how we do it. But we know that the angle must lie between 0 to pi. That is, it can take the value 0, it can't take the value pi, but it must lie within this range. So if I write minus pi by 4 does not lie in this range, so I can't write this. So I have to find another different angle for which tan theta will be minus 1. So therefore, if the minus is absorbed inside, it becomes pi minus pi by 4, because we know in second quadrant tan is negative. So therefore tan theta becomes tan 3 pi by 4, and hence theta is 3 pi by 4. Fine. So this is how we find the angle between any two lines, for the matter of fact. Here I am given x-axis and a line, but if I would have been given two lines, I would have also done the same thing. If it becomes negative, then I must always do pi minus that angle instead of writing negative of the angle, because I have to ensure the angle lies within that particular range. Next, now we move to the main topic, a topic which is very important for rest of the chapter, that is equation of straight lines. So there are several different forms of the equation of straight line. You already know few, but we are going to deal with all those different forms of the straight line one by one. So let us first know what are the forms we have. The first one is point slope form, which we already have studied. The next is point form, that is a 2-point form, which is also something we know. Slope intercept form is also something we know, which is also one of the most common form of straight line. Then we have intercept form, then we have normal form, then symmetric form, and finally the general form. Now in today's class we won't be discussing all the different forms. We are going to limit our discussion to the first 4, that is till intercept form, and in our next class we will be taking up the other 3. So to start with, point slope form, which is also another basic form, that is, if I have a point given on the line, that is, we know that the straight line passes through that particular point, and we also know the slope of the line. In that case, the equation of the line is given by y minus y1 equals to m into x minus x1. M is the slope. Fine. Then next one, point form or 2-point form. 2-point form means if I am given 2 points on a line, instead of the slope and a point, if I am given 2 points on a line, then the equation will be given by y minus y1, that is equals to y2 minus y1 by x2 minus x1 into x minus x1. So basically what you are doing, you are actually finding the slope here itself. So in the previous case, the slope will be given ready-made. You won't have to find it. Here in this case, you are actually finding the slope and then you are putting it in the formula. So that's just it. So point form and point slope form, there is not much difference between the two. Next, we have the slope intercept form. Now to understand the slope intercept form, let me first draw this graph. We have this graph with us. So there is a straight line. This blue line is depicting a straight line, and it is intersecting the axis at these 2 points. So it is intersecting x-axis at this point, it is intersecting y-axis at this point. So the point at which the straight line intersect the axis, the distance of that point from the origin, so this distance here and this distance here, these distances are called the intercepts. They are called as the intercepts. And the intercept made on y-axis, it will be called as the y-intercept, and the one which is made in the x-axis will be called the x-intercept. Fine. So now for the slope-intercept form, by now you understand that there should be two things given. One is the slope of the line, and then I should know one of the intercepts. Now which intercept should I know? We need to know the y-intercept. So if those two are known, then the equation of the line is given by y is equals to mx plus c. Fine. Simple enough. Y equals to mx plus c. So I need to know the slope, I need to know the intercept, that is particularly the y-intercept, and then the equation of the straight line will become y is equals to mx plus c. Now if the straight line passes through origin, instead of it is intersecting the axis, if it passes through the origin, say if the straight line would have been like this, in that case, you see, if it passes through the origin, then there is no intercept. The intercept will be 0. Why? Because when it is passing through origin, it is not intersecting at any point on the axis. So therefore, for that kind of a line, the equation becomes y is equals to mx. There is no c here, so it will be y equals to mx. Next, the intercept form. Now in the intercept form, if we know both the intercepts, so let me call the x-intercept as a, the y-intercept as b. So if we know these two intercepts, or rather the points on the axis where it is intersecting, so if we know that, then the equation of the straight line is given by x by a plus y by b is equals to 1. And always remember that this intercept form is the plot friendly form. Plot friendly means if you want to plot a straight line on a graph paper, then always try converting the straight line into the intercept form. Then it becomes very easy for us to plot it. Why? Just let me give you one small example. Say I am trying to plot 2x plus 3y is equals to 6. Say. Now we know the drill how to plot it. So what we do, we just make a table. We try finding out those points which are on the line, and then we need only 2 points, and once we find those 2 points, we can plot it. So what we do, generally we put x as 0, then find the value of y. We find the value of x when y is 0. So basically if we do so, then this is your 3, 0 and 0, 2, right? But instead of doing this, we can do a small trick to it. What is the small trick? You see, 2x plus 3y, that is equals to 6. If you divide the whole thing by 6, what do you get? X by 3 plus y by 2 equals to 1. And basically this 3 and 2 are your intercepts. So it is giving you the point basically 0, 2, and it is giving you the point 3, 0. So you are just going to plot it using those 2 points. So you don't have to make a table also. Just by converting it into intercept form, directly you can plot it without drawing the table. So therefore intercept form is also called a plot friendly form. Means if you are trying to plot it on a graph paper, then it is always good to convert the straight line into intercept form. Fine. So now let us move to few more problems and then end the class. So for first example, or chronologically the fifth example, find the equation of the line passing through the point minus 4, 3 with slope half. So what are the things given? You are given a point and you are given the slope. So you are supposed to make use of the point slope form. So point slope form, the equation of the line looks something like this. Put the values, calculate, and you get this as your answer. Now there is no hard and fast rule that you have to keep everything on one side and put the right side as 0. You can just leave your answer like this also, no problem. Fine. Next, Number 6. Find the equation of the line passing through 2, 2 root 3 and inclined with x-axis at an angle of 75 degree. Now, we know if the inclination with x-axis is given, so tan of that angle gives you the slope. So tan 75 degree is basically tan 30 plus tan 30 plus 45 degree. Use the compound angle formula. Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. So just put the values. Your slope comes out to be root 3 plus 1 by root 3 minus 1. So you got the slope. You already given the point. So now we just put it into the point slope form. This is how it looks like. Now the calculation, you can do it in any way you want. So I have just cross multiplied and then I have just side transpose and simplified, and I have kept my answer just like this. You could have gone another step further and you could have done a little bit more if you want, but keep your answer like this, no problem. Okay. Number 7. The vertices of triangle PQR are 2, 1, minus 2, 3, 4, 5. Then find the equation of the median through the vertex R. Now, just if you forget what is a median, so let this be R, this is P, this is Q. Median means this is the line segment, so let this be S. So it is the line segment or the line passing through this opposite vertex and through the midpoint of the opposite side of the vertex. So therefore first job will be to find the midpoint of the side PQ, because we are asked to find the median through the vertex R. So I have to find the midpoint of the side PQ. So let me do that. So midpoint of PQ, if you do your calculation, then this is what you get. Then I need to find the equation of median. So you already know the 2 points, that is R and the midpoint. So now you just put it into the formula, calculate, and hence you get your answer this. Fine. Go through the calculation once, check it for yourself, do it, try it. I'm sure you will get it. Next, number 8. Find the equation of the line passing through the point minus 3, 5 and perpendicular to the line through the point 2, 5 and minus 3, 6. So the situation, always remember, if you visualize the situation, it becomes easy for you. So you are given a situation something like this. This is perpendicular. This line is passing through the point minus 3, 5. This is told. And also it is told that it is perpendicular to the line segment joining 2, 5 and minus 3, 6. Right? So what I can do, I can first find the slope of this line, that will let it be m. Then if this slope is m, then minus 1 by m is going to be slope of this perpendicular line. So once we know the slope of this line, we are already given a point, then we can use the point slope form to calculate to find the equation of the straight line. So now let us just do it. So what is the slope of the line passing through this 2, 5 and minus 3, 6? Do your calculation, it comes out to be minus 1 by 5. So therefore the slope of the perpendicular line will become 5, negative reciprocal of that. And then the equation becomes y minus 5, that is this point, y minus 5 equals to 5 into x plus 3, and that gives you y equals to 5x plus 20. Simple problem. Now the last problem, problem number 9. Find the equation of the line passing through the point 2, 2 and cutting off intercepts on the axis whose sum is 9. Now you are told, say this is the straight line which is passing, this is your x-axis, this is your y-axis, this is origin, and it is told that this intercept plus this intercept, the value of the two intercept, that is equals to 9. So therefore if I take one of the intercept as a, the other intercept becomes 9 minus a. Fine. I can say that. So if I can say that, so therefore the equation of the straight line can be written as, in the intercept form, x by a plus y by 9 minus a equals to 1. We know that if we know the intercepts, then this is how we write the equation. Now it is told that it is passing through the point 2 comma 2. So if it is passing through the point 2 comma 2, it must satisfy the equation. So we can put and we can solve. So therefore if we put and solve, that is 2 by a plus 2 by 9 minus a equals to 1, and after so many steps, I have jumped a few, you get this 18 is equals to 9a minus a square, and then you have a quadratic equation. You go on solving, you get the value of a as 6 and 3. So if you get the value of a as 6 and 3, so therefore the value of b also becomes 3 and 6. So it means when a is 6, b is 3, and when a is 3, b is 6. So therefore you get two different equations of line, and one is x by 6 plus y by 3 equals to 1. The other one is x by 3 plus y by 6 equals to 1. So basically the idea is, if this is 3 comma 0 and here there is 6 comma 0, here I have 0 comma 3 and here I have 0 comma 6. So the line will pass something like this. So this is one of the lines and this is the other line. I'm so really sorry, this is the other line. Fine. So this is how it is in both the cases. The sum of the intercepts is 9. Alright, so this is our first class. We will meet once again for the second class, and as always, get your doubts clarified if you have any. Thank you.